In this video, I wanted to go through the last problem, 6.7 in the lab 6. And only because we haven't used this tool before, I wanted to show you kind of how to do it because it is a little weird, it's a little strange. This one does have a built-in way you can do diagrams or timing diagrams in the circuit. The deal is you have to create a sys clock, and a sys clock is just something that's just attached there. It's basically how often it's going to sample. So this is under the wiring, and if you go clock, it's right here. You literally just take the clock and put it on the screen, name it sys clock, which if I click on this, you'll see it's a named sys clock. I've got 1 tick each for the settings, and then my clock, what I want it to be, I want it to be set for 4 ticks each and called clock. So that's really the only stipulations. The rest of it's just very straightforward. You've got power, which is right here under your wiring. There's your power. Ground for ground, right here. And just tie those together. Tie these to an output of some kind. I like to call them out Q and out Q not. Apostrophes won't work there, unfortunately. And so now, once you do this, you want to go to the simulate menu right here. And you want to set the tick frequency to 4 Hertz. So the tick frequency, we want to set it to 4 Hertz. So this will give us a 1 Hertz clock, which is perfectly fine for what we're going to do. Hey, so when you're ready to go, you may notice it looked a little different because they updated the version, so they changed some things around. So this is an updated version of this lab simulation or demo. So what you want to do is click simulate and click timing diagram. And it'll pop up saying you've got multiple inputs, which one, or multiple clocks, which one do you want? Click sys clock and hit OK. And then you'll get this window pop up at the bottom. Sometimes it won't show this window at the bottom. It's sometimes it doesn't show it, sometimes it does. So it just depends on how big your monitor is, things like that. If it does not show it, click on window and just do timing diagram and it'll pop up. And you can make this full screen as well. So let's just make it big. And so this is the main screen you'll pop up on. You can not do anything with anything except here, add remove signals. Click on that. And you'll see it's going to show everything. We don't want everything shown. So you can get rid of sys clock. So click it and then click the over arrow just to get rid of it. We don't really need the JK flip-flop part. We can take that out of there. And we've got our 2 outputs, a Q and the Q naught and the clock. That's the input and then the output. Hit OK. And then if you click on timing diagram at the top, you'll see that we've got our clock, our Q output, and our Q naught output. And you notice it's not doing anything right now. So we have to basically turn it on. We have to run it, right? We have to simulate it. So if you click this little, like this little check mark with a green play button at the bottom, if you click that, it'll start running. And it'll run through as many cycles as you let it run. So we'll let it run for a little while. And then I'll stop it. And then you can see what it looks like. So basically we got our clock sitting there going every 4 Hertz. No, that's not even 4 Hertz. Anyway, every 20 microseconds, it's toggling, right? 0, 1, 0, 1, 0, 1, 0, 1. And then our output, ignore Q naught for a second because it's just the opposite. So our Q is every positive edge of the clock, the Q is toggling. So you can see it goes high. When that goes high, this gives a positive edge. It goes low. It goes high. It goes low. So we're basically halving the frequency. We're cutting the frequency in half, but it's also going to be counting up as we go through. And so anyway, that's how it works. And when we get to counter circuits in the next section, you'll see how they all relate to each other. It actually does count up in binary. But for all intents and purposes, all I want you to see is every positive edge, the Q output will change. And the same thing with Q naught, even though it starts opposite, every positive edge of the clock, it's going to also toggle to the opposite state. So yeah, that's it. That's all I want you to see, get it working. That way you can be able to simulate signals.